Hi everyone, welcome back to Pine Hollow Auto Diagnostics. Today we're working on my own 1996 Mercury Mystique. It has a slight issue with the cooling system. Now the engine doesn't overheat, actually it doesn't warm up enough. I don't think. So if you look at the gauge cluster, the little temperature scale, so I've owned this car for a couple years now, and usually the needle rises to right in the middle there between the R and the M and just hangs out. That's the normal thermostat opening point, so like 200 degrees Fahrenheit. Recently though, it's been colder and the needle barely makes it to the N. It just hangs out way down low. So at first I thought, oh, maybe the sending unit for the gauge is going a little out of calibration or whatever. But then I hooked up a scanner to monitor the exact temperature, and I was only getting up to 160 degrees Fahrenheit. Now it was warming up quickly, but then it would just stay there. It wouldn't go up to 200 like it used to. So, why is that? And the heat in this car is actually really good. And I've been noticing that, I have the heat turned up all the way, and it's, it's okay. But in these cold, it's getting a lot colder, so I want nice heat in my car. And I want to address this issue. So just by the symptoms, that really narrows it down. The only thing it could be is a thermostat that opens early. It's not stuck open, it's not stuck closed. The set point is just too low, like 40 degrees or so. I looked up the OEM specifications. It's supposed to open at 197 degrees or 92 C. So that's way above what it's doing right now. So I got a brand new OEM Ford thermostat in stock. Let's put it in, run the vehicle, and see what the temperature gets up to. So the thermostat itself lives right where the upper radiator hose attaches to the thermostat housing. It doesn't look too bad to get to. We'll pop off this air resonator chamber and it should be accessible. Alright, let's get started here. Let's get this air box out of the way. Just one clamp there, and then I'll just pop off the air cleaner housing. This clip hits the connector always. Gonna have to slip it by, and then don't forget to unplug our mass airflow. This whole shebang should lift. Don't want to damage the air tube. Hey, still an original air tube, not like those Hondas that like to crack. Alright. Oh, and our intake air temp sensor. Perfect. Hey, we can already see the thermostat. Always a good idea to make sure we don't have any mice in the airbox. Looking good there. So here, I want to probably just pinch off the coolant reservoir fill pipe so we don't lose all the coolant in the reservoir. So just this guy right here, you're gonna clamp in there. It's a pretty soft hose, so you don't want to damage it either. Maybe a little bit further on there. There we go. So pinch that guy, and then I figure I'll just take this off, and whatever coolant leaks out, we'll put a catch pan underneath. It's pretty high up, so we shouldn't lose that much. And hopefully it's a straightforward process. Alrighty, so there's the thermostat housing. We have to undo these 3 8mm bolts. Should come out pretty easy. I think it's a plastic housing. That's 2, and the lower one we can use a little longer extension. Hopefully get around this upper radiator hose. Now the less connections you disturb, the better. Now, I don't want to take the hose off the housing just because it's not leaking now. Don't want to touch it. Let's get a catch pan. I already see coolant dripping. So I'm just going to undo these bolts. Not all the way, so we can crack it, let the coolant drip out as much as it wants. Oh yeah, this is pretty straightforward here. There we go. Perfect. Don't drop anything. Wow, anti-seize. I think the previous owner replaced it at some point in the car's life. Now this car had a whole bunch of cooling hose issues, meaning explosions, and there we go. It overheated several times, and it's still kicking, so good job Ford on the head gasket design. Out of here. You see this car, for a 4-cylinder, it's packed. It has all kinds of hoses and pipes, and if you look at a Toyota from the same era, there's so much room everywhere. You know, this thing is like, to get to anything you have to kind of peel back the onion. There we go. Well, that's not too bad at all. Make sure we're catching all the coolant. It's looking pretty good. And here's our thermostat. This is like gonna be like a 10-minute video. Can we get this far enough to squeeze this guy out of the way? There we go. I wish all thermostat replacements were this easy. I want to know in the comments if anyone's tried an Audi V6 thermostat replacement where you have to take the front end off and the timing belt just to get to the thermostat. German engineering. So this guy actually is a Motorcraft part. The owner didn't mess around. He put in good OEM parts. So, I don't know. Let's get the new one. I got it right here. There you go, Motorcraft parts. So I don't know if they're only supposed to last 2 years. Should be the exact same replacement. Looks identical. Same part number, same everything. I should have gotten a new gasket. We'll have to reuse this guy. And for good luck, I've had issues sometimes where this gasket actually still seeps a little bit. So I like to put a little gray RTV around it and then stick it in the housing, just for extra insurance that it won't leak down the road. There's a new unit. There's a little jiggle ball at the top. Let me wipe this down, put some RTV on it, and we'll slap it back in. I don't know if it's the cold temperature or what, but this stuff is like really congealed in there. We don't need much. What the heck? This is supposed to be the easy part. Definitely don't want any solid chunks. Alright, slip the new guy in there. Make sure that the spring goes towards the engine block. And how do we slip it in here like this? Make sure I can hold on to it without dropping it in the bucket. It'd be nice if that EGR hose wasn't in the way, right? But the old one came out, so this one should go in somehow. Oh man, come on. Is this why they tell you to take everything apart before doing the procedure? I'm gonna get everything in this gray stuff. There we go. Get in there. Alright. Looks good. Line it up. Put the bolts back in. Straightforward, nice and easy. Just the way we like it. The previous owner really paid attention to detail. I mean, anti-seize on your thermostat housing bolts. I don't think I would go that far, but it's nice that they did. Sure makes repairs go a lot smoother, especially if you live in rusty, salty states like Pennsylvania or New York. And we don't want to over tighten these. It's all plastic, remember. Nice and easy, just to seat the gasket. And last but not least, the bottom one. In the service manual it says you have to take the whole housing off. I don't know why. Maybe so you can get by that EGR pipe. Alright, good to me. Release the clamp. And this system should self-bleed. You see this upper hose here? All the air should just purge right out into our coolant tank. So how does this thing fill the radiator? Well, you see the hose goes down there, right to the lower hose. That goes into the radiator, comes out, and into this line here. So let's top it off to max and see if it fills up. So here's how much coolant drained out. Maybe a couple quarts. And if Scotty Kilmer was doing this, he would put this right back in the system. Hardcore like that, but we're gonna do it the, the other way. Alright, let's see how much that'll fill. You see the level? It was up at max and now it's going back down, so the system is filling. Let's keep going. I love this spill-free funnel. You can fine control how much fluid you're putting in. Alright, it's back down to the max. Actually looks perfect right there. About 2 quarts. So how Ford designs this, the level of the coolant tank is actually very important. See the level there? It's level with the radiator top, so it fills up to the level in the tank basically. So this hose right here, that's just air. But there is coolant in this hose, you can hear it. And the engine block should fill through the little bleed hole. Might take a little while. Then there's another hose that goes from the thermostat housing across and down into the lower radiator hose. So this is the bypass hose. We could do a separate video on cooling system designs. I kind of find it fascinating, you know, the different types, the pressurized, you know, just the radiator cap and a non-pressurized overflow, or in this case, this whole system's pressurized and the cap is just the vent, you know, vent the extra pressure. There's no coolant going through this cap, unlike, you know, a Japanese system where the radiator cap bleeds off extra coolant into the overflow tank. Each system, I don't know, I mean, they both work, so it's just a different design. I guess this tank, since it's plastic and pressurized, it has a higher chance of cracking, but this is a 1996 original, so I guess they made that one with enough quality plastics to make it last. So how the bypass hose works, let's say you have a cold start, thermostat is closed, there's nothing going, you know, into the upper radiator hose. What's happening is the coolant is actually going into the bypass hose, right back into the lower hose and back into the engine. So it's like a closed loop without the radiator. Once the thermostat opens up, then the hot coolant goes into the radiator, gets cooled, and then back into the lower hose. So not too hard to comprehend, but let's fire the beast up and see what temperature we get. So just for the quick temperature check, I don't feel like, you know, booting up a scanner. This is a really cool tool. The ELM 327 OBD2 adapter, Bluetooth, pairs up with your phone, and we can use an app to just look at OBD2 data. So we're going to plug this baby in here. Little LED lights up. You can see that. So all we need to do now is boot up the, let's see, the torque app. That's what I use, OBD2 check. And with the key on, you'll see that it establishes communication to the vehicle. So the car's blinking, so it's trying to talk to the car. And here we have a very nice interface where you can read fault codes, clear them, see the car turn solid, so we're talking to the car. What we want to do is real-time information, and here you can customize your data list, and all we want to do is look at the coolant. So right now it's at 51 degrees. So we're going to fire the car up and see how long it takes to heat up and what the set point is when it actually starts, when the thermostat opens up and it starts dumping the hot coolant into the radiator, and it should just stabilize there. And let's say we want to do a bar graph over time. We'll just hold the screen, add display, and we want a graph, and we just look for, where's coolant temp? Might be engine coolant temp. There it is, engine coolant temp. Select that guy, medium, drag it down here, and now we have a graph and our dial indicator. One more thing, while the car's warming up, set your heat to hot and make sure you get warm air coming out of the vents, because if you don't, that would mean that there's an air bubble trap, the system didn't bleed properly, you can overheat your engine very quickly, so watch out for that. So it's let's see, it's 2:39 right now, and our phone escaped. You can get over here. Oh. There's our, right now it's at almost 90 degrees. In any case, we're warming up. I'll flip the camera back on when we stabilize, and that means the thermostat is going to open up, Our needle's gonna find its happy spot and stay there, and the coolant is gonna be forced into the radiator, and this temperature should stabilize. Also, while the car is warming up, we want to check for leaks, any drips. There's our thermostat housing in there. It's a little wet from the spilled coolant, but the pressure, so if it was a radiator cap system, the pressure would build very quickly. In this case, we have all this expansion room. You see the coolant levels rising already, but the pressure will build much slower. Just keep that in mind. You know, you'll squeeze the hose, like, hey, there's not much pressure in there. Well, it'll take a while to build up. Alright, so I'm happy with that. To speed up the process, we can give it a little throttle. Make sure all the air bubbles are out of the system. Let's see, we're at 130 now. That's going up pretty quick. The needle just starts moving only at 130, so that's just how it's calibrated. So your usable range is from like 130 to 230, or until it overheats. The fan actually on this thing, I find it kind of weird. You know, the thermostat opens up at 200. The fan only kicks on at 230, so your needle gets up to like the L in normal, and you kind of start freaking out. And then the fan kicks on, and then it starts dropping again. So some needles just stay in one position. The temperature is more exactly controlled. You know, it goes up and down like 10 degrees. This one is just programmed. The fan is only programmed to kick on at 230, which is a little warm. So we're at 150, still climbing. And once we break 160, we'll be past where the old thermostat opened up. And I guess this graph is more or less useless. I mean, if it only graphs over 9 data points or 9 units, I don't even know what those things are. Are they seconds? Probably seconds. Alright, we're at 162. We got nice warm air coming out of the vents, that's good. Okay, so the temperature seems to have stabilized at 189 degrees Fahrenheit. Our needle is a lot closer to the middle where it used to be. So even though I'm revving the engine, the temperature is staying rock steady. At 190. There'll be a slight fluctuation. The thermostat's supposed to open at 195, so close enough. And it's not on or off, it's a very gradual opening. And under the hood, you want to make sure that the upper radiator hose is starting to get warm. The thermostat opens up. So it's still pretty cool. It's getting a little warm right here. So the thermostat is just starting to open up. Pressure is building nicely. Beautiful. I like it. Still at 190. The heat is toasty. It's much, much better. So that's where the needle likes to be, right on the R of normal. That's pretty cool. It's like gradations. You can get a pretty fine temperature measurement. So still 190. I see it dropped to 188, so the thermostat is slightly open right now. All right, that's it. Mercury Mystique is pretty much ready for winter. Just gotta get the snow tires on and we'll be good to go. Thanks a lot for watching. Hope you enjoyed that little coolant system explanation and repair. And I'll see you guys next time. Bye-bye.